Can you see my screen?
Yes, it's clear. Yeah.
Okay. All right. So, hi everyone, and welcome to this introduction to Pandas class. So, Pandas is a very popular library, for doing data analysis, data manipulation, and almost everything that you can do with structured data. Okay, so it's very, very popular in the field, and it's very, very popular among Python developers. So for researchers, for people, beginners who are working with structured data, mostly in tabular forms like CSV and the rest, maybe Excel, even SQL data, you can easily um, import this data into Pandas and programmatically manipulate these data. Okay, so it's an open source library, and it's freely available for use. You can easily install it using your normal pip install. So you can easily do that and use it in a notebook environment. So today we are going to be using it from the Google Colab environment. So in Google Colab, you don't need to pip install it. I'm assuming that most of you are familiar with how to pip install packages. So, but on Google Colab, if you're working locally, maybe in your notebook, in a local notebook, you don't need to install anything. You have to install Pandas by using the pip install. But since we are working on Colab, which is a free and hosted platform, it has already been installed. So Pandas basically give you syntax like SQL. If you've worked with SQL before, there are lots of similar syntaxes, like for example, for merging data, for grouping data, for printing the head, printing the tail, and in combination with that, you have lots of access to things like mathematical operations that you can perform on data, on rows, on columns, and stuff like that. Okay. So to use Pandas, first of all, we have to import it. Okay. So I'm going to import Pandas. It's popularly given an alias of PD. Okay. So in most textbook, in most tutorials, you always see import Pandas as PD. It's like a de facto standard. All right, so we import it. I also imported NumPy because we might use it later, but it's not. You don't have to import NumPy if you want to use Pandas. So please just take note of that. So I import Pandas. I'm going to run this cell. Okay, done. Now, before we get into Pandas, it's important to understand. Hello, Ben. I think you have to mute yourself. Okay, so before we get into Pandas, I'm going to introduce two new data structures to you guys. So Pandas is basically built on two main data structures. And when we talk about data structures, I don't know if these are the same set of people I taught object-oriented programming some weeks back. Okay, but if you were in that class, I talked about data structures. Okay, they will say that the list is a data structure, your dictionaries are data structures, floats, strings, these are all data structures because they define a way of of they define a kind of how do I put this? They defined what type of data, what properties the data should have. Okay, so they're like a class on their own that defines accepted and unaccepted attributes, definitions, and things that you can do to that particular data. Okay, so in Pandas has its own data structures which are built around something called series, which is this, and data frame. Okay, so series is just a fancy name for, it's like a list. Series is an advanced list. Okay, so in the sense that what you can do with a Python list, you can do with series, and you can do much more. Okay, so I'm going to show you that very soon. So there are lots of things. So series is a one-dimensional object, like a list or a column in a table. So if you've worked with Excel before, for example, you know you have rows and you have columns. So a particular column or a single row can be likened to a series, which is similar to a list as well. Okay, but in Pandas, series can take any type of values. Can take numbers, can take mixture of numbers, strings, and different kinds of things. And there are many and numerous functions that you can perform on series. Okay, so and the opposite of, not exactly the opposite, like the extended version of that is data frame, which I'm still going to introduce to you as well later. Okay, so but just take it that data frame is a combination of multiple series. So it's like a table. Okay, so you have lots of series in that table. So data frame is made up of multiple series. Why series is just a single data structure or a one-dimensional data structure. Okay, so also I should also mention that Pandas is built on top of NumPy. And if you are familiar with NumPy, NumPy is a mathematical library built in C. So if you know, if you've heard of C programming language, you know that C programming is a low-level language that is very fast. Okay, so NumPy was built in C, and then they built wrappers, Python wrappers on top of it. So what you are, when you execute a function or a command in NumPy, you are talking to the C internal, the C library under it, or the C language under it. So that's why NumPy is very, very fast. Okay, so Pandas was built on top of NumPy. So that means you have access to the same speed. Okay, so you have access to the same speed that NumPy has. So take note of that. Okay, so we're talking about series. So I said series is a one-dimensional object similar to an array, a list, or a column in a table. So you can assign a label to each item in the series. Okay, so in the case of this, now this is a single. Please try to mute your mic if you join so that you don't distract us. Okay, so for instance, this is a list. This is a Python list. Okay, if I run this cell, this is a Python list. So I can assign it, for example, let's say I call this 10. Please mute your mic. Please mute your mic. Percy, I think, what's her name?
I think they use screen protector.
Can you mute it? All right, thank you. All right, so for instance, this is a list. So we have 10 equals to this list. Now you can see this list is a mixture of integers, this is float, and this is a string. Okay, so you can do lots of things with this list. So for example, if I want to access, say, the third element in the list, I can do something like this. It gives me 1 to the third element, so 0, 1, 2. Okay, so but in contrast to list, a series is more. Okay, so a series assigns an index to each value of this particular integer, of this particular list. Okay, so that, for example, if I want to create a series from a list, a Python list, you just need to take the list and pass it into the series object here, or the series class here. This is a series class. So you have pd.series. So if I remove this, do something like this. So you see, say it's a one-dimensional ND array with axis labels. Okay, so you can see it's expecting a data. All right. So if I pass in this, so for instance, let me pass in temp. Temp is a list. So if I pass in temp to this place and print it out, I'm going to be having this. So you can see I have 1, 2, 1, 20, 30.7, and it's automatically assigned an index to it. So you can use this index to what? To reference any of this value. Okay. So one difference between list and series is that you can use any value of your choice as an index. Okay, so you can actually change the index. So you can see in this particular place where we have this new list, so this is a list, we are creating a series from it, and then we are setting our own index. So you can see this is another parameter, index. So we're setting A, B, C, D, and E corresponding to 1, 2, 3, 4, and 5. Okay, so if you run this cell now, please mute your mic. If you run this cell, you can see this is now the new index. So you can't do this in a traditional Python list. Okay, so take note of that. So if you want to access, for example, Nigeria, you can access it using the list. So Nigeria, the index for Nigeria is B. So I can use S of B. Please mute your mic. Test C. Okay. So are you guys following? Let me check. Let me check the chat session because are we all following? Because if you are following, just notify me in the chat session.
Yes, you can go ahead. I'm following.
All right. Okay. So we can index any of these values using a particular index. Now you can see it's similar to what you did in the list. So here you have temp 2. So this 2 corresponds to the index of this list. So in the case of a series, you are indexing from the index name. So you can have S of B to give you this. Okay. So also you can also construct a series from a dictionary. So remember we created this series from a list. So you can create a series from a Python list. You can also create a series from a Python dictionary. Now, if you use a dictionary, remember a dictionary always has the key and the value. So you have key and value, key and value. So if you construct a series from a dictionary, it's going to automatically assign each of the key as the index, while the corresponding value will be your values. Okay, so you can see this is a dictionary. Chicago 1000, New York 13, something like that. Then you have cities, which is equals to pd.series. Then you pass in that dictionary. So automatically it's going to take these keys and make them your index, and take these and make them your values. Okay, so you have that. So that's also another way of constructing a list. So there are two popular ways, like by passing in a list and by passing in a dictionary. Okay, so we can also index just like we've seen before, cities of Austin. So you can see it's very easy to index if you know the label, if you know the index, you can easily get the value. Okay, also you can index more than one item at a time. So you can pass in a list of index or a list of labels to the cities. So cities is a series already. So if I pass 2 index, which is Chicago and Portland, so I have Chicago here and Portland, it's going to return those 2 values. So you can see it's going to return those 2 values as a new list. So I can assign this, for example, I can assign this to a new variable called, let's say, call it 2 cities. So if I run this cell, I'm going to select just, let me create a cell above. It's going to select just these 2. Maybe I should zoom in a bit. Let me zoom in a bit. Okay. So it's going to take just these 2 corresponding values and return them as a new series. So meaning you can use it to subset your data. So you can see it returns Chicago and Portland corresponding to Chicago and Portland. So if you know the index, you can simply just pass more index. You can try to pass in posting here. Now it's no longer 2 cities. So let's call it 3 cities. And if I print this again, I have this none, which represents no value. So you can see none, no value. So meaning there's nothing, there's empty. Okay, so we have that. All right, so also you can also select values by using something called Boolean indexing. So Boolean indexing will return the result of your query if it is true, and if it matches your condition, your Boolean condition. So for example, if I have something like this, cities greater than 1000, Okay, so if I print this out, for example, let me take this here. Now, what kind of command is this? I'm comparing cities to 1000, but know that cities is a series. Okay, and if you are comparing a series to an integer, it is going to be comparing the values, not the index. Okay, because this is city, this is city, this is the index, this is the value. So whenever you are comparing a series to a value, it's going to be comparing against each of these values, not the key, not the index. Okay, so for example, if I say is cities greater than 1000 and I print this out, it's going to return booleans. So true, false, true, false. So true if yes, city is greater than 1000, or false otherwise. So you can see the key and the boolean, the key and the boolean. So in the place of Chicago, it's telling you that Chicago is not, the value of Chicago is not greater than 1000. Is that true? Let's confirm. So you can see this is 1000. So it is equal, not greater than. All right. So what about New York? New York is 1300. So that is greater than 1000. So it's supposed to be true. Yes, and we have true here. So that's why you have false, true, false, true. So this is called Boolean indexing. So what we are doing, we can take this Boolean index, which returns false, true, false, true, false, false, and use it to select values from a series. Okay. So meaning just in the place in this place where you have where you normally pass in a label that you want, you just pass in the Boolean condition. So you are saying return cities, yes, cities is greater than 1000. So what it's going to do is going to, first of all, get this. After getting this, it's going to pick out only the value, only the rows, or only the particular value that it's true. So it's going to return New York, it's going to return San Francisco in a new series. It's going to remove this, this, and this. So if I do that, for example, I call this large cities and I run that, you can see the result below. Hereby it's going to only return where it is true. Okay, so you can do as much query, you can even combine queries together. So you can do, let's say, where it is, let me say, here it is less than 1000. So I'm going to do something. Let me try something like this. And let's say cities is equal to let me look at the values. Less than 1000 equal to, let's say, 900. So before we run this, what do you think the answer would be? Let's trace it. So we are saying cities should be less than 1000 and cities equals to 900. So return only those values where cities is less than 100 and it is equal to 900. Okay, so if you look at our original series, less than 1000, we have Portland and Austin. Austin is 450, Portland is 900. So that means we are going to be having, normally the first query is supposed to return Portland and Austin for us, okay, because they are less than 1000. But the second query, which must also be true, because we are doing and, so meaning year must be true, year must be true for this query to pass, okay, is that cities should be equal to 900. So after eliminating the first three, which gave us Portland and Austin, we are left with Portland and Austin. So it said it must be equal to 900. So meaning this is the only value that's going to be returned. So let's see if this should be on. Invalid syntax. Okay, I should probably use and. Let's try this. True value of a series. Oh, I think I know the issue. Let me quickly search this. I've not used this in a while. Comparing multiple booleans in a pandas Okay, just give me a minute. So this is common. So most of the time when you start using pandas, there are lots of things that you get. Okay, so whenever you run into this kind of issues, the best thing to do is, for example, you can just copy this error, paste it in. You can't see my other screen. You can just paste it on Google and try to understand it. Sometimes it's just a simple command that you've probably forgotten. Okay, so let's see. Let's see.
You only use one end, the other end, the two double ends that you used before, you just removed one and then you use one.
Okay, I have good students here. Since I have good students here. Wow. Then you guys should be taking this class now. But that's nice. Oh, somebody even mentioned it in the chat session. Thank you very much. So you see, even if you've used this for 10 years, there are still some things that you'll forget. All right, so you can see now we were able to add multiple Boolean queries together. And so you can see the power of pandas. It's very, with just this intuitive and easy structure or easy command, you can easily retrieve particular data points that you want. So it makes things very easy. If, for example, you wanted to implement this in, say, maybe SQL, it's going to be a little bit longer. So you see, power of pandas. That's why pandas is very, very popular. All right. So that's for Boolean indexing. Then okay, this is what I explained on top there. Then you can also change the values in a series on the fly. Okay, so for example, you want to change a particular value. Say, for instance, let's say Chicago, which I already did here. So print the old value of Chicago is what? 1,000, 1,500. That's the old value of Chicago. Okay, and comment this out. If I print this out, so you see I have 1,000. Okay, so now if I want to change this value, if you know the key, you can easily change the value. So it's very simple. So it's as simple as that. So I can just say cities of Chicago, assign it to a new value. So let me assign it to say 2,000, for instance. And now if I run this, and this is the old value, 1,000. If I print out cities again, you can see it's going to change the value. Now this change happens in place. So if you use pandas a lot, you would have heard of something called in place. In place means that it is changing the original data. Okay, so if you said it happens in place, it means the change happens to the original data. That's why you were able to do this assignment here, and it affected the original data set. Okay, now sometimes you can see places where you have in place equals to false when you're trying to do some stuff. So that means that you don't want the original data to be altered. So you are instead creating a new data set from your query, from your command, or from whatever you've done. Okay, so please take note of that, because most of the time you do not want to alter your original data set. You want to make a change and save it to a new variable. That's where in place comes into place. So you see in lots of pandas function, you'll be seeing in place. Do you want in place to be true, or you want in place to be false? So take note of that. All right, so you can easily change values, so you can do that. Can change values using Boolean logic as well. Okay, so for in this case, we say yes, these are less than 1,000, and I think we have just one. Since I have changed, let me see. How is this so? Okay, we have two, right? So 900 and 450. So you can use a Boolean query to update the value. So for example, if I want to update where cities are less than 1,000, I want to assign 0. So I want to assign 0 to Portland and Austin. Okay, so you can easily do this. Mention equals to 0, yeah? If I print this now, which you've done before, so you see it as a placed it with 0, 0. So take note of that. Very easy to do. So also, what if you aren't sure whether an item is a series? You can easily check using idiomatic Python. Very easy. You know, Python as a language makes writing programs very easy because it uses kind of like English-like syntax. So you can see something like this: busting in cities. So it's like you asking if um, um, this particular index is in your value cities, it's in your series cities. Okay, so and that can easily tell you that's true. Yes, there's Boston in city. So what about if I do a city that is not there? So for example, if I say let's say Accra, there is no Accra in city, so it's supposed to be in what? False. Okay, so you can easily check different cities, different values like this, or different commands like this using basic idiomatic Python. So this is the same thing we did here. So if I run this, we do that. So, okay. All right. So now we want to move to some other properties that make series very, very great. Okay. And much advanced than your traditional Python list is that you can perform mathematical operations on series. Okay. So mathematical operations can be done using scalars and functions. So for example, using this our series we've created already, cities, you can add two or more of them together. So for example, I want to combine Chicago, the value in cities of Chicago plus the value in New York together. So you can add them together using the plus function. Okay. So this can easily combine them together and you can have the value. So for example, maybe you want to use the value to do something, you can easily do that. Okay. So you can divide as well. So for example, city is divided by 2. This will do what we call broadcasting. So broadcasting in the sense that since you are dividing the whole series by 2, it's going to take this 2 and use it to divide each as individual individual value like this. So it's called broadcasting. All right. So take note of that. So if I do divide by 2, it's going to divide this by 2, this by 2, 0 by 2. So that will give you 0 as well. This by 2, this by 2, and this will also return none because it is not a number. Okay, so take note. So you can do this. You can also do, for example, I can also do multiplication. So any mathematical operation that you can do on Python, you can do it on this as well. So if I say times, let's say times 2, it's going to multiply every value times 2. Also doing what we call broadcasting. So, okay. So you can also apply NumPy functions to series. So remember I told you that NumPy Pandas was built on top of NumPy. Okay, so NumPy supports Pandas directly as well. So you can apply functions and methods that you have in your NumPy to series easily. So how can you do that? For example, you want to sum all the values in your cities. You can just do np.sum to give you that. And also note that you should also notice that Pandas on its own has its own inbuilt mathematical operation. Okay, so you can see if I do cities dot, because cities is a series, it's going to return all the possible functions and things that you can do with cities. So you can see there are very many. Okay, so you can see add is here. I can do cities dot add 2, and this will give you exactly the same thing that we have here, something like this. Like when you use the normal plus sign. Okay, we're going to divide. So let me do div. I think there's a div function. Yeah, there's a div function. You can see we give you exactly the same thing that you have. Where is it? Cities div 2. Oh, it's giving me a different answer. Oh, I forgot that we multiplied here. All right. So you have something like this. All right. So, but what the Pandas developers did was that they did something called overriding. Overriding in the sense that you can use normal Python plus add and stuff like that. Okay, instead of explicitly stating the function like div or add or sub and things like that. So you can just use the normal same but operators like plus minus, and mathematical operations like that. So take note. So you can do it this way, or you can do it the easier way using the operators symbols. Okay, so you can also add two series together, which returns a union of the two series with addition on occurring and shared index value. So if you are adding two series together, they should have the same index or the same size. Okay, if they don't have the same size or the same index, Pandas will return null or none in place of it. So take note of that. Okay, so for example, we have cities. You can use the not null function to check which of the values are null or which of the values are empty. So not null is asking, is Chicago null? Is Chicago empty? So it's saying true. It is not null. It is not null, and it is true. But Boston is false because why? It contains none. So there are lots of functions like that. There's also one called is none. I think I did it here. There's is none. There's is none. Is NaN. So you can there are different variants of that. So this city that is none is telling that is this particular value empty, true or false? So Chicago is not empty, that's why you have false. This is not empty, but Boston is empty, that's why you have true. So it's none and not none, and not is null and not null are like opposites. So you can see the values, they are opposites. So take notes, depending on what you want to do. Okay. So I was going to mention something. I said, hey, you can add two series together. So for instance, let's say I have, okay, let me just add this cities and cities. See, I'm adding this to cities. So I'm going to be adding these values here together. So that's like multiplying by 2. So you can see, you can easily just add them together. So if you have, for example, cities in one column and a particular another series, you can easily add them together, you can multiply them together. In fact, you can do anything, any mathematical operation on it. So for example, let me just create, let me say cities updates, for instance. Call this PD dot series. Yeah, that's it. Let's give me a minute. Let me copy. Yeah, we created the cities. Okay. I'm going to copy this. I'm going to modify it. So I'm going to modify it. I'm going to add, let me say Boston 200. I'm going to add Accra to be, let's say 800. I'm going to add Lagos to be, let's say 1000. So I'm going to create a new city, a modified city from this. So let's see, cities update. So this is our new city. I'm going to try to add them together. So I'm going to add cities plus cities update together so that I can show you. Okay, now you can see that it's going to combine, let me bring this down a bit. It's going to combine both of them together, and for new values that are not in the other series, it's going to return none, just like I said here. So you can add two series together, which returns a union of the two series. So it's going to return both keys, the keys that are both present here. So we have Chicago as 1, 2, 3, 4, 5, 6, 7, 8. It's going to return the 8, which is this. It's going to return the 8, but if this key is not present in the other series, it's going to return none. It's not going to add them together. It's going to return none for you. So take note of that. So he said values on either series that do not have a shared index will produce a null or a none. So take note of that. Okay. Okay, no questions so far. But if you have questions, you can type them in the chat sections. But so far, let's continue. So that's for series. So take note. So just a quick recap. Series is like an advanced list or an advanced dictionary kind of, or an array, not dictionary. So, but it allows you to perform numerous operations like mathematical operations. You can do addition, subtraction, sum, things like that. You can do Boolean querying. You can do subsetting, and there are lots of things that you can do with the Pandas series. So it is very, very flexible and easy to use. Okay, so I'm going to add to this notebook some links to the Pandas documentation where you can get to know more about sales. So now let's move on to data frame quickly. Okay, so a data frame is a tabular data structure comprised of rows and columns. So you can think of a data frame as a spreadsheet or an Excel table or combination of multiple series together. So if you've seen something like a grid of tables, and I believe everyone has seen an Excel, or you've seen a CSV file, so you can see there are rows and there are columns. Here the columns a particular name, it has like the same values in a particular column. So you can have maybe a string column whereby all the values in that place are strings. You can have an integer column and things like that. So a data frame is basically that. So it can be of any shape. Maybe it can be 2 by 3, can be 3 by 4, but you have 3 rows, 4 columns, stuff like that. So it's an extended version of a series. So most of the things that you can do with a series, you can do with data frame, but there are some functions that you can only perform on data frames. Okay, so how can we create data frames? Now you can create data frames also from dictionaries. I think this is the most popular way of creating data from dictionaries. Hereby you have, for example, year, team, wins, and loss. So this represents the column name. So this is a list of values. So these values represent what this column is going to be holding. Then we have a comma. The next one is team, all the names of the team. Then the next one, which is wins, all the names of the wins and losses that has happened. So from this dictionary or from this data, we can easily create a data frame, and it's going to put it in a tabular structure for us like this. So you can see pd.data frame, pass in the data, which is this, then the column names, which is this. So for instance, I think Pandas can automatically create a column from a dictionary. So let me try that. I think it can do that. So let me try that. Yeah. So there's no need to pass in that index. But for instance, if you want a new column name, you can easily do that by setting the column attribute. But since you are creating a data frame from a dictionary, it's going to automatically take these names here as the column names. And that's true because for year, the value of year is this. So it's going to take this as the column name, which is this, and assign all the values to that particular column. Now, also take note that, for instance, if I have, each of these have 7 entries, so 7 rows, 4 columns. So what happens if I have a column that is less than 7? So for example, I remove 2012 and run this. It's going to throw an error. It's going to tell you that all the arrays must be of the same length. So whenever you are creating a data frame, they should all be of, all the values should be of the same length. X Pandas is going to throw an error. So you can see this is a very nice data. It has structured it properly into rows and columns for us, so you can easily manipulate this data. Okay, so what are the kind of things that we can do? We can also do our Boolean selection. So for example, football of losses. So if you want to select a, let me do that up here. If I want to select a particular column, so let's say I want to select year or team. Let me select team. So we put that in quote. If I run this, it's going to return a series for me. It's going to return a series of all these teams. So this is a series. Okay, so whatever you can do with a series, you can do with a particular column in a data frame. So I told you that each data frame simply comprises of a series. So this year from year downwards is a series. This is a series. This is a series. This is a series. So they are all just combined together to make a data frame. Okay, so let's move on quickly. So football of teams can easily get that. So you can easily use that to subset. So I'm saying return all the rows where football of losses is less than 5. So if you do that with your eye, since we have a small data, so this is losses, this is 5, 5, 1. So they say less than 5, so meaning this is the only answer is going to return. So that's why we have just that one. So, but if I do less than or equal to 5, it's going to return 3 rows for me. You can see, because they are less than or equal to 5. And also, it's going to be returning their indexes, their specific indexes. Okay, take note of that as well. So, meaning index 0, index 3, and index 4. So, you can see the data frames are very, very powerful. Now, most of the time, if you will be reading in data into data frame, you won't be really creating your own data frame like this, just in some rare cases. So most of the time, you'll be reading in data for maybe Excel, CSV, JSON. There are very many. So Pandas gives you methods to help you easily read this kind of data. So if you just do, let's say pd dot, let's say read, so you can see there are lots of things that you can read data from. So clipboard, for example, if you do copy and if you copy something, you can read it from the clipboard. Read CSV, Excel, fader, HDF, HTML, JSON. So you can see there are very many. Echo, SQL, SQL query, table, things like that. So you can, the most popular one used here is mostly CSV. Okay, so that's what I'm going to demonstrate below here. So you can see pd.read CSV. I'm reading this particular CSV file. So this is like a path to the CSV file on my local machine. So take note that read CSV also takes in URL. So you can read a data from a URL source. Okay. So I think I should I even do that? Let me just do that. But before I do that, let me show you how to read this file locally. So on Colab, I have to add this file first. So let me quickly add this file. This is the file. Okay. So I'm going to add the file. I'm going to, but if you are on a local machine, you don't need to upload it. So I'm going to copy the path to the file and put that here. So this is the file path. Okay. So if I run this now, okay, I think I now have the file, so I can do .head. Now I have access to the file. So this is the file. So I've been able to read a CSV file. If you know CSV file, they are comma separated values, comma separated variables. Okay. Let's see. I think there's a way you can preview. Can you preview? Or you can't preview. Yeah, you can. I think there's a way you can preview files on Colab. Okay. Well, let's leave that. It also formatted it for us. So I wanted to show you guys this comma separated values, but no, I think we've seen it before. So it's going to read those values and pass them into a data frame structure. So you now have each of the column names. So these are all column names, and the corresponding values. So notice that each of these are series on their own. So there are lots of things that you can do with them. So you can query it, you can update it, you can subset, you can fill missing value. There are lots and lots and lots of things that you can actually do with this. So for instance, let's say supermarket of product price. This is product price. I think product price. Yeah, so it's here. Product price, yeah. So for example, your boss or somebody in your office tells you that, okay, I want you to return all the entries where the product price is greater than 600. Let's see which people are paying more or which kind of products are people paying more for. So to easily do that, just do supermarket of product price greater than 600. Very easy. And you can easily run this and get your values, get your results. Okay. Get your values and get your results. So you can see I have about, I think it should be 70. Is that 70? Oh, 270. about 270 rows or 270 instances whereby the price is greater than 600. So you can investigate these files. What kind of instances are these? Are they unique? So for example, I'm seeing low fat, low fat, low fat, low fat. Okay. I'm seeing dairy, soft drinks, household, household, household. So probably you might start to get an understanding that okay, maybe people pay more for products that have, say, low fat. I'm just guessing. So normally as a data scientist, you don't just make decisions like that. You have to investigate this. It could be that the sample I'm currently seeing just happens to just contain low fat, that's why. So, but I'm just telling you that things that you can do with pandas, you can use it to query your data set, to analyze it, to manipulate it. There are many things that you can do with it. Okay. So there are some popular functions like the .head to take a quick look at the top 5 functions for a data set or 5 instances. So the head also accepts the value, so I can decide to say 20. It will easily show the top 20 entries. Okay, so there's .head, there's .tail. So .tail is the opposite, shows you the last entries. There's also .sample, which will randomly sample the number of elements. So for example, if I do, let's say 5, you randomly pick 5 elements for me. This is good in places where you want to maybe just get a feel of what data, how this data sampling strategy is. Here's it. So this is it. So you can see it picks 419, this, and this. So there's also another important and popular function that can help you give you a quick description of your data. Okay, so you can do describe. So describe mostly work on your numerical features. Okay, numerical features are just those that contains numbers. So it gives you like count, mean, standard deviation. These are all called central tendencies. Gives you like a quick definition of how many values are there. So if there are missing values, it's going to tell you. So for example, the total number of entries is supposed to be 4,990. But you can see for product weight, we have 4188. That tells you that there are missing values in this particular feature. But for this, we have 4990. For this, we have 4990 as well. Okay. So we have that. So 25%, these are all percentiles that you can quickly look at. There's a maximum and there's a minimum. Also, I think there's also another one called info. So you can do supermarket data.info. Also gives you description. You can see this also gives you a description of the data. So you can see product name, which is the column, then not null, that how many not null values are there. So you can see supermarket size 3540 means there are missing values. It also gives you the data type of each of those columns. Okay. All right. Then you can also do things like data.shape, which tells you the shape of the data. So we have 13 columns and this also number of features. Before. Then this is like advanced, not even advanced, it's kind of easy because we did this the series already. Whereby we compared multiple Boolean queries. So I'm trying to get where product price are greater than 600 and the supermarket opening year was 2014. Okay, so let's run this query. So what we are trying to get is to get modern supermarkets that sell at prices greater than 500. So if I run this cell, I can easily get that. So let me print. So you can see, so this one can pay that. Oh, these are the modern supermarkets type 2, type 2, type 2, type 2. You can see they are all modern. So you can see there are lots of things that you can do with pandas. Also, there's also a function called unique. Yeah, this one you can apply it on a single series. And you can easily get the unique values in that particular column. So you can see we have low fat, ultra low fat, normal fat for product fat content. Okay, you can do that for you can also do something called value count. Value count is similar to unique, but it will tell you the number of times each of those unique values appear. So for low fat, we have 3039. So you can see it, low fat is very, very popular among the data set, that among the instances in this particular column. Okay. There's also the unique. Okay, I've shown you unique. This was for market type, with value counts as well, and things. So this is just like a brief introduction to Pandas. There are numerous functions that's available that you can use. But the thing is that most of the time, what you want to do is you just have to search for it. Okay. So for instance, you want to maybe add two columns together and you can't remember the syntax, just go online, go to Google or go to the Pandas documentation. There are lots of this is that you can. I think I should just add it here. Pandas documentation. Let me just add it. So take note of that because it's very important. You don't have to memorize all the terms. In fact, nobody does. Nobody memorizes all the terms because you just can't do it. So, but as you start using it often and often, then get to remember most of the most important one that you need to use. Okay, so please take note of that. So, are there any questions at this time? This is just like a brief introduction. I believe you've learned one or two. So, are there questions, concerns at this time?
I don't have a question. I think you're quite clear in all your explanations.
Okay, that's good. That's good to hear. Okay. If there are no questions, then I think we're good to go. And okay, so I'll just quickly give you an exercise for the next session. So before our next session. So what I want you all to do is to use Pandas. This data set, I shared it with you all. So it's to use Pandas to explore this data set and give me some of the important insights that you're able to find out from it. So for example, what are the highest product price possible? What is the most popular supermarket? What is the most popular products that they sell? What is this? So just use your discretion and try to just analyze this data set using just Pandas. Okay. So for example, for medium-sized supermarket, what is the highest price or what is the total price sold, total cost of products sold by the supermarket of medium size? So just ask questions like just assume you are the boss of a company or you own this particular supermarket and you want to try to understand how customers behave or how customers are interacting or how customers are buying your product. So you ask these questions and analyze it, try to answer it using just Pandas. Don't use any other tool, just use just Pandas for it. Okay, so that's the exercise. I believe you guys can do it. You guys can do it. It's something that you can easily come up with. So at least you have maybe like at least like 10 questions that you intend to you ask yourself and you answer using Pandas. So that's your exercise for the week. And so I think we're good to go. So, Brian, is there anything that you need to share with them? Emmanuel, any other person in this call? Okay, I don't think there's another person in this call. But since you all understand, I think we are good and good to go. So, I'll see you all next time. Take care. Have a great weekend. Have a great week and have a good time learning. And ensure to do the exercise. So, thank you and bye.